Derivative of a to the x using the chain rule. Earlier on, I explained that a to the x prime is equal to a to the x times ln of a, right? But I deferred to after learning the chain rule because the proof of this requires the use of the chain rule. Now that we know the chain rule, I can explain why this is true. And it's just a few lines of calculation. It's just straightforward calculation. So the way we do this is first think about a to the x as e to the ln of a to the x prime. Okay. That looks horrible, but it is true because ln and e cancels. You know that, right? If you cancel e and ln, then what's left? That's a. So you get a to the x power just like this. So going this way, it's easy to see. It's hard to think about from here to there, but that's what we need in order to prove it. Now the next thing that you need is that if you have e to the m to the nth power, when you have a parenthesis like this, the exponential rule says that you have to multiply them, right? So we're going to use that and rewrite this as e to the ln of a times x prime. Okay. So along the way, this is what was actually done. So we were able to write down a to the x as e to the ln of a to the x. And therefore, differentiating a to the x is the same thing as differentiating this right side. But wait, this is something that we know how to differentiate. You can treat this as big X. So it's the derivative of e to the x, where this, what we're calling it as x, is really this inside function ln of a times x, right? And the inside function has to be pulled out, and you have to differentiate it. That's the chain rule. And because ln of a is a number, don't be fooled. It looks like a function, but it's really a number because a is just a constant, right? It's a constant multiple to x. So this is really a coefficient of x. Any coefficient can be moved outside the derivative, so you're really just differentiating x, which gives you 1. So you end up with e to the ln of a x times ln of a times 1. Now let's see, what was this? This, we argued that this is the same thing as a to the x, right? So you get a to the x times ln of a times 1. It doesn't do anything, so there you have it. That's how you get this formula.